What is crack-a-lackin', guys? I'm coming at you with another video. This one is on Bitwise functions. If you have not watched the registers video, I would recommend going back and watching that one. That's just kind of a continuation, a little bit of some of those ideas and concepts. But let's just get into it. So basically, a big part of firmware is being able to manipulate and send the correct bytes of data that you want to send, from one embedded system to another embedded system, or to check those kind of bytes of data. And a way that we are able to do that is by using bitwise functions. There are a lot of bitwise functions. Today I'm just going to go over bitwise and bitwise or, because those are by far the most prevalent, and they also, like, just for the complexity of it. So let's just get into it. Just for overarching concept, bitwise and, basically how this works is that unless both of your bits are 1, then they're going to be 0. So if you have variable 1 is 0 and variable 2 is 0, then it's going to, if you bitwise and those together, you're going to get 0. If variable 1 is 1 and variable 2 is 0, and those together, you're going to get 0. So on and so forth. And the only time you get a 1 is if you do variable 1 and variable 2 are both 1, then you would get a 1. For bitwise or, also for the bitwise and, it's just the and symbol is how you would see that or display that in C. And then for bitwise or, it's if either one of them or both of them, if they are 1, then you get a 1 as your output. So if variable 1 is 0 and variable 2 is 0, then you get 0. But every other time you get a 1. So if variable 1 is 1, if variable 2 is 1, or if both of them are 1, you get a 1. Quick rudimentary example of that is if we were to OR this top number with this bottom number, basically wherever you see a 1 on either of them, you get a 1. So you get a 1 from this first column, another 1 from this column. Because these are both 0, you get a 0. 1's from this column, 2 zeros here, you get a 0. 1 from this column, and then you get a 1 from this one, 1 from this column. Then if you were to bitwise and the exact same numbers together, as you can see, you get a lot less 1s. These two 1s would become a 1. This would actually be a 0, 0, 1, 0, 1, 0, 0. So bitwise and OR on their face, very, very simple. It's just kind of logic at that level. And I'm going to get back to those in just a second. But for this next thing, I'm going to talk about something called bit masks, which are a very commonly used thing, which basically bit masks are used as they're generally in hexadecimal, and they tend to basically be a position in decimal in a weird way. So if we look at this, what's presently variables on our right here might be a little bit confusing, but our variables are on the right, and let's say they correspond to the bit mask of hex 1, which would be binary 1, hex 2, which would be binary 1, 0, and then so on and so forth. And as you go up and then all the way up here, you get a full, this is a full byte here of, 8 positions in binary. And each of these bit masks corresponds to a different one of these settings. If you remember from the registers video, these were some of the things for the heat and motion sensor. So let's pretend that these were the bit mask for the heat and motion sensors, and these would be provided to you in the data sheet saying, hey, if you were to do enable heat or heat enable, these are the bit masks that go to them. So you're kind of wondering, okay, what do these bit masks have to deal with? Well, if you look a little closely, you see, okay, if I set this first bit high, then I'm enabling the device. If I set the second bit high, I get heat enable, and it kind of like separates each bit out into the function what you want it to do. And what does that have to do with bitwise ands and ors? Well, we'll get to that in just a second here. So let's say we wanted to enable our device and enable heat and motion sensor and have high sensitivity. So to write that, we would need to put the address, which we're just going to say is hex 0 because it's simple, and then we have to do comma and then 1111000000. And that is really, really bad because it's unreadable. Like, if you don't have very intimate knowledge of the device, you're not going to really be able to read this very well. You just be like, what does that mean? And if you forget about it, it's really easy to mess up. So a better way to do that would be you would have a specific address in your device you would define. Preferably it'd be, at the top of your document, but just for simplicity's sake, I'm just going to put it right here. And you say, okay, I have an address of 0, and I'm going to write data to that address. And then the data I'm going to write is, and then I'm going to bitwise OR all of these together. And that might seem a little confusing now, but essentially what we're going to do here is for enable, which is just binary of 1. Actually, we're going to do this a little bit differently. We're going to do binary, let's do this from the back, actually. From high sensitivity, it's going to be binary of 1, 0, 0, 0. And then if we bitwise OR that with the binary of 0, 1, 0, 0, that is motion enable, and then we bitwise OR that with the binary that is 0, 0, 1, 0, that is heat enable, and finally bitwise OR that with just the enable, what we would get is, if we were to do this conversion, okay, go from the top, we get a 1 here, we get a 1 here, a 1 here, and a 1 here. Basically, when you bitwise OR something with these bit masks to each other or to something else, you're basically setting that specific bit high, which is exceedingly useful because that basically means that, okay, if I have these bit masks, I can basically just say, this is a setting. Now, it's like, you don't have to think about it in binary, this is a setting. And then how I add settings is I bitwise OR them together. So I have an enable setting. Boom, I want to bitwise OR that with the rest of my settings so that I get all 4 of my settings. And that is one of the most common ways that you'll see the bitwise OR used, is basically it's a way to add, to make sure that a certain bit is high, and it's a way to have a certain setting be used. So then you might be wondering, all right, where does bitwise AND fit into this? So bitwise AND can function in a kind of different way. So let's say we have the data, a variable data, and that is equal to when we read the data from that configure address. And the main thing we want to do is check if there is a temperature fault. So if data ANDed with temperature fault, and then be like, oh, stop car. So you're probably wondering, okay, how does data AND with temperature fault, how does that equal us going into that if statement? Well, first off, in the basics, if any number greater than 0 is the expression in the if statement, then it's going to evaluate in true in C. So if this is 1, if this is 2, if this is a million, it's going to evaluate to true. So let's see what happens here. So the thing about data is that it can be a lot of different things. You know, let's say all those first 4 bits are high. Excuse me. You know, the enable, actually those would be the bottom 4. So enable, heat enable, motion enable, high sensitivity are all high. Medium, low sensitivity are low. And we don't know what heat enable is. And let's say that the motion interrupt is low as well. Basically, we don't care about every single bit here that isn't X, right? And that's the only thing we care about. So if we were to AND this, bitwise AND this with our bit mask that is the temperature fault. So then if we go 0B, 0, 1, 0, 0, 0, 0, 0, it's basically going to set every single other bit to 0. And so that means that we are only really comparing the 7th bit, this bit, and this bit to each other. And this is extremely useful because, as you can see here, otherwise, how else could you check just that one bit, see if there's just a temperature fault? And so then if you were to evaluate this, you would just end up getting 0, whatever that variable, whatever that X is, 0, 0, 0, 0. And then you could actually check and see if there's a temperature fault very easily. I hope this video was helpful. I hope you guys are all learning everything to the best of your abilities. And I hope to talk to you guys soon. Thank you.